In this video, let's explore the new .NET AWS message processing framework by using it to send and receive messages from Amazon SQS. We will first have a quick recap of the native way of working with Amazon SQS from .NET and then see how the new messaging processing framework helps remove a lot of boilerplate code and makes it extremely easy to work with SQS. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. Here I have an existing solution open which I had used for the video Amazon SQS. Now if you're completely new to Amazon SQS, I highly recommend checking out that video which will be linked here and in the descriptions below. It's very good to have a basic understanding of how Amazon SQS works and the different features and properties that SQS provides that we can use while setting up our messaging applications. Now on this video, I'm going to highly cover some of these properties, but will still be more focused on the message processing framework rather than on SQS. So here, this is an ASP.NET application with the weather forecast controller. So to send a message to SQS, we had to use the SQS NuGet package and create an SQS client and send a message request. Now sending a message request involves setting up the queue URL, the body, which is the serialized content of a message that we need to send, and then send the message using the SQS client. Now we also had to set up a receiver to receive the messages. Now normally the receiver would be in a separate process and would be hosted and running separately to your application that's usually sending the messages. Now in this case, I decided to host it as part of a Windows worker job, and I have a weather forecast processor here which is running as a background service. Now in this application, I added a background worker service that listens to the messages in SQS and processes it. So we have the weather forecast processor, which is a background service class, and all this does is loop through and call the Amazon SQS and check if new message has received or not. So we again create the SQS client and we loop through infinitely until the whole process is cancelled, and we call the receive message async on the SQS client. This again has the queue URL and has specified some properties additionally. Now once a message is found, we process the message. So this is the core business logic of our message processing handler. The rest all is actually boilerplate code which is required to talk with SQS and send and receive messages. The AWS message processing framework simplifies the development of .NET message processing applications that use AWS servers. So one thing to keep in mind is that this message processing framework is tightly coupled with AWS services. Now there are other libraries like Mass Transit and Service Bus, etc., which work across different cloud stacks and also are great messaging framework. However, this is very opinionated and used specifically with AWS. So if you are building applications on AWS, this might be a good one to check out. Now this framework is currently in developer preview and some of these features might change when the actual release comes out. However, most of the fundamental concepts will be remaining the same. Now the message processing framework reduces the amount of boilerplate code and also allows us to focus on our business logic. Let's see this in action. So here I have a default ASP.NET API application, and in the program.cs we have controller method which is the map get. Now as with everything, to start using the .NET message processing framework, we need to add a NuGet package. So let's right click on our project and say manage NuGet packages and search for AWS messaging package. Now let's install this. So you can see that this is 0.9.2 and this is currently in developer preview. So let's add this to our project and start using this. Now to send a message, I will create a new post endpoint where we will be able to add a new weather forecast data. So let's add a new method in here which is for the map post. Let's take in the endpoint which is again going to be the weather forecast, and this is going to be a post endpoint inside that endpoint. So let's take in a parameters. Let's leave this for blank and let's create the function first. Now let's also specify the with name and specify a name for this. So let's say post weather forecast, and let's also specify with OpenAPI and also specify disable anti-forgery so that we can send messages using the Swagger UI. So once we have that set up, let's start using this to send a weather forecast data. So we can take in a weather forecast data object, so which is the data that we are currently posting to this endpoint, and you could have functionality inside this code to save this to your database or do other processing logic. Now this is going to be specific to your application and the business process that you're going to use. let's more focus on the sending and receiving messages part. So let's say once we've received a weather forecast message and done the processing, we need to publish a command or an event that this specific thing is done. In this case, it would be an event because this is a side effect of an action. So there is a weather forecast added event. So let's first create the weather forecast added event inside our class. So like the record, we can also create a new class or even a record. So let's specify this as a weather forecast added event. And we'll have again some of these properties like the date time, which is the date for which this is particularly published. Let's also specify the actual temperature, which is the temperature C property. And let's also specify the summary that's coming in. So that's going to be a string. So we have three properties inside here on our event, which is going to get published as soon as we add a new weather forecast data. So to publish the messages, let's take in an interface from our AWS messaging library. So let's use the SQS publisher, which you can see is coming from AWS messaging.publishers.sqs. So let's take in a dependency to this, which we will register into the service collection a while later. So let's take this as a publisher. So let's make sure to add the appropriate namespace and let's use this publisher to publish our message. So in this case, we can specify publisher.sendAsync and send the new message. So in this case, it's going to be the weather forecast added event. And let's also specify the properties. Let's specify the properties from the data.date. Let's also specify the temperature C, which is going to be data.temperature C, and also the summary, which is going to be data.summary. Now we have specified all these properties and we're going to publish this specific event. Now, since the summary is nullable, let's also leave that on our event as nullable. So let's make sure that's there and let's specify this as date time. So now we have sent a new event as soon as the weather forecast is added. Now to get this to work, we need to make sure that the SQS publisher is registered and injected into our service collection. So let's do that next. So let's navigate to the top and let's go to the builder.services and set up our AWS messaging process. So let's specify builder.service and use the method add AWS message bus. Now this again is coming from the NuGet package and it allows us to set up the message bus. So in this case, this is going to take a builder and let's set this up using a function. So we'll first need the queue. So let's specify the weather data queue. Now in this case, we can hard code the URL in here, but you can also put this in application configuration. So if I navigate into my AWS console, I have two queues created in here. So I have a weather data queue and also a weather data dead letter queue. Now a dead letter is whenever the messages on the main queue are not processed, those messages will end up in the dead letter. Now this could be because of an exception or timeout, etc. Now I highly recommend checking out my SQS video to understand more about these. So let's navigate into the weather data and let's copy this queue URL and use this in our application. So let's come back and let's paste this in here. Now again, this could come from an app settings.configuration and you can check out my configurations video on how to set this up, etc. Now once we have that, let's call the builder.add_SQS publisher because in this case we are using SQS to publish the message and we have also set up the SQS publisher to send the message in our endpoint. So let's specify that and let's also specify the event that it's getting published. So in this case, this is going to be the weather forecast added event. Now we can specify the queue URL, which is the weather data queue in this case, and also a unique name identifier for the message. So we can simply use the name of and specify weather forecast added event. So it's going to use the name of the event as the name for that specific message. So we have set up the SQS publisher now in this case, which means we will have a valid instance of SQS publisher when this method is getting invoked. However, we also need to handle this message. Now, like before, you can set it up on a separate process and run it separately. The process would be the same. You will have to install the NuGet package and set up this method so that you can set up the receiver in that particular project. However, let's see in this same application. Let's add a new handler that will handle this specific message. So let's create a new class again. So let's specify class weather forecast added event handler and let's say that this is going to handle that specific event. So in this case, we can use the iMessage handler, which is again interface coming from AWS messaging, and specify this handles the weather forecast added event. So let's make sure to implement the missing members, which is the handle async method that gives us the message and also a cancellation token. Now we can do the appropriate message handling logic inside this handler. Now this could be sending an email or doing some recalculation of reports, etc. Now this again depends on your business functionality. So let's keep the core business functionality aside, and in this case, let's simply write this to the console. So let's specify console received weather forecast event with certain data. So let's use string interpolation and map out some of these properties. So in this case, we can specify the message envelope dot message dot datetime. So this is going to be for this datetime, and let's also specify a few other properties so that we know which message this is. So with the temperature C, etc. So we simply console right lining that specific handler. Now, since this is returning a task, let's simply return a return task dot from result, and let's specify message processor status dot success. This is because this is now successfully processed, and we are returning a success object in this case. So if you navigate into that method, you can see this is simply a helper method which returns an underscore success that again is creating the actual type, which is the message processor status, with an enum value of success. So let's come back to our program.cs. Now once we have the handler, we need to register the handler inside the startup. So let's scroll back up into the add AWS message bus and register the handler part. So let's specify registering handler. Let's use the builder.add message handler, which is going to be the add message handler extension method. Let's specify the weather data added event handler in this case, which is going to be the handler that it's going to handle. And let's also specify the event that this is handling. So in this case, this is going to be weather forecast added event. Now again, we can pass in an optional message type identifier. So let's specify the name of weather forecast data added event. So we have registered the message handler. Now we need to set up the actual process that's going to look for the messages in our SQS queue. So let's specify the builder.add poller, which is the add SQS poller, and configure this. So in this case, this again requires the queue URL, which is going to be the weather data queue, and we can specify an optional options. We will see that a while later. So let's just specify the queue name and set up the SQS poller. Now this is going to do all the background heavy lifting job of looping through and talking to the SQS and receiving messages from that. Once the messages is received, it will call the appropriate handler. So let's run this and see this in action. So let's make sure to put a breakpoint in the post method and also in our handler code. And let's run this. The Swagger UI is up and running. So let's use the post, try it out, and let's send a message. So let's specify the temperature as 10, and let's say the summary is cool, and let's click execute. Now this is going to hit the breakpoint. It's going to send the message first. So we have the publisher.send. So we have the SQS publisher injected in. So we have successfully sent the message, which is going to the Amazon SQS, which we have set up inside our poller. And once our poller starts polling and looks for the message and it's successfully received, it will invoke our handler. Now, since our handler hasn't been invoked, looks like there is some issue in our setup. So if we look at the console, you can see some exceptions inside here. So in this, it says it does not have a valid subscriber mapping for message type identifier weather forecast added event. So if I come back to our configuration and look at this, you can see that I have specified the name as weather forecast added event handler. However, this needs to be added event, which is the event that we are handling this for. So once we fix this, let's run this again. Now we have a message that's in the queue already, which means the handlers should get invoked as soon as the application starts up. So now our application has started up and our poller would have started polling for messages. So let's run this again and let's send another message. So let's go into the post, try it out. Let's specify the temperature again as 10 and let's specify the summary as cool. And let's click execute. Now this is going to again publish the message like before. And since we have set up the handler appropriately, it also invokes the handler code. So now you can see this is going to do the console write line and return a task success result. So you can see in the console now there's no errors and it logs successfully. So this has now successfully published and received a message using Amazon SQS with very minimal code. We only had to focus on the core business logic and the entire boilerplate code is being abstracted away from this library. Now, what happened to the earlier message that we sent? Now that has actually ended up into the dead letter queue. So you can see here that in dead letter queue, now there is one message. Now this is because there was no handler for our particular message at that time, and the message got retried a couple of times and still didn't find a handler. So it moved to the dead letter queue. Now you can reprocess this message by navigating into the dead letter queue and say start dead letter queue redrive. So if I specify redrive to the source queue, in this case I have set it up to the other main queue that we have. So let's specify dead letter queue redrive, and that immediately sends that message and a handler receives it and it logs on the console. Now that message is also successfully processed, which means all our messages in the queues are now empty because all the messages has been successfully removed from here. Now what happens if there is an exception when processing the message? So let's say in this case, once we receive a message, we can specify the message envelope dot message, and let's check the summary property. So if this contains the word exception, we will throw an exception. This is an easy way for me to simulate an exception. Now in your case, this might be a real use case or something that's unhandled inside your code, or something that you are talking with which throws an error or an exception. So let's throw an exception in this case, and let's simply specify the summary itself. So let's specify the message dot summary. Now in this case, it's going to throw an exception and not return a success code. So let's run this and see what happens. So we still have the breakpoint. So let's run this application again. Let's execute with the normal message. So in this case, this sends the message and it receives it, and it also processes the message successfully because there is no word of exception inside the summary. However, the next time around, let's write cool exception and let's execute this again. So in this case, once it's sent and the message is received, it's going to pass through this loop and throw a new exception. Now, as soon as the message is thrown as an exception, it means it's unsuccessfully processed. Now, by default, the setting that we've used on the message and on the message queue is the default message timeout of 30 seconds, which means once the message is processed, it will put back in the queue for another consumer after 30 seconds. So you can see that after 30 seconds, our handler gets called again because the message was placed back into the queue, and it gets sent back to our message handler because a new message has appeared. Now this is going to continue in a loop based on a setting on the retry count that we have set in the SQS queue. So if I navigate back to my SQS queue, if I go to the weather data queue, let's look at the edit settings, and here you can see I have set up the dead letter queue inside here and specified the retry count as 2, which means the message will be retried to a maximum of 2 times, after which it will be moved to this dead letter queue. So you can see in our case, the message was retried twice because it was delivered to us 2 times, which means it should be in the dead letter queue by now. So you can see there is a dead letter queue message inside here. So if I navigate into that, you can do send and receive messages, and you can actually inspect the message inside here. So if I click this, you can see that this is the message that we've sent, and it has the words cool exception. So once you handle your code or fix it appropriately, you can replay these messages so that the handler will pick it up again. Now, if you want to have more number of retries, you can adjust this setting inside this. Now, this is particularly useful for certain cases where you rely on eventual consistency, or where there are intermittent network delays or errors which might cause exceptions as well. So in that case, when you retry, the exception would go away and the normal processing flow would continue. Now, we can also customize the setting of the poller when we set it up. So when we had specified the add SQS poller, we can specify an option in here. So it takes in the SQS message poller options. So let's specify the options, and we can configure this inside this method. So on the options, we have different properties like visibility timeout, wait timeout, etc. So if we specify the visibility timeout, which is by default set to 30 seconds. So if I set this to 5 seconds, we'll also have to specify the options.visibility extension threshold. And let's keep this as a number lower than 5. Now, once we have the visibility timeout to 5, it means the message will be sent back on the queue and available for next processor after 5 seconds. This also means we should be able to complete our processing within 5 seconds. In this case, we will be because we are just writing to the console. So let's run this again and let's see what happens in this case. Now, if I again put a message with cool exception inside the text, it's going to send the message through an exception. So it's going to process this this. Now it's gone and thrown the exception, but the message is going to come back much sooner in this case because the visibility timeout is 5 seconds. We didn't have to wait for 30 seconds for the message to be redelivered. And you can see that the message is reprocessed and this will go back into the dead letter queue. So now if I navigate into the weather data and edit this property, and let's change this to 3 and let's save this, which means the message will be retried 3 times. So if I go into the queues, go to the dead letter queue and start the dead letter queue redrive, and let's redrive that message. And now this time it's going to get sent 3 times. So you can see it's already sent us and we have received the message and processed it. And this time we received it 3 times. And it'll again end up in the dead letter queue because it wasn't successfully processed. So if I navigate back to the dead letter queue, you can see that message is back in there. The messaging framework also works with Amazon SNS. So if you want to know more about that and see a video on that, let me know in the comments below. If you like this video, please make sure to hit that like button. If you want to be notified of future such videos, please make sure to hit that subscribe button as well. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.